Hello, Jessica. Please switch on your camera. Hello, am I audible to you?
Jashita, you are not audible.
Hello, ma'am.
Hello.
Yeah,
Yeah,
you are
Jessica.
not.
Yes, ma'am.
Please switch on your camera if possible. You
Yes.
can interact. Hi, Jessica. How are you?
I'm okay, ma'am. How about you?
Doing good. Jessica, you want to discuss ray optics for today?
Yes, ma'am.
Okay. Have you done it before, or is it for the first time you are doing it?
We have done it before in school.
Okay, okay. So you want to start it from the basic, or you want to discuss the optical instruments? We
Yeah.
can start with the basics, mirror formula, lens formula. What do you
Uh,
want to
can we
this?
start from the laws of reflection part?
Laws of reflection. Okay, fine. We can start with the laws of reflection. Great. Is the board visible to you?
Yes, ma'am.
Okay. Okay. So let's start with the laws of reflection. See, you have one chapter is the ray optics, another one is the wave optics. So in both the cases, we are discussing about the different phenomena of light, and here we are discussing the ray nature. So let's first focus on this ray nature. Optics, that is about like the that is study of the light. Okay, and when we are saying ray, that is something you have learned in mathematics in the lower grades, that ray is something which has one end point, right? And another point, another side, you can you can extend it indefinitely. So when we are considering the light as a ray, means there is a source of light. Let's say this is a source of light, sun, and that is coming in that definitely all the directions. Now, why I'm talking about it? Because when we are considering the light as ray, we have certain phenomena as reflection and refraction of light. Okay, these are explained using the ray picture of the light. So, firstly, let's start with the reflection. If we are talking about reflection and refraction, both of them are the bending of light, right? One thing is common, that here also it is bending of light, here also it is also bending of light. In case of reflection, we call it as bouncing back of light from polished surface. Okay, means, for example, when a light is falling on any polished surface, any mirror which is polished from one side, which is painted from one side, so when the light will fall over it, this is our incident ray. Okay, so it will get reflected, and it will get reflected in the same medium. So that means incident ray and the reflected ray, both of them are in the same medium, right? And this angle is the angle of incidence. This angle is the angle of reflection. Now, what is this angle of incidence? That is the angle between incident ray and normal. What is normal? Do you know about normal?
Yes, ma'am.
What it is?
It's just a line, like a perpendicular line to the.
surface,
Yes.
reflecting surface. Okay. And this is the reflected ray. Reflected ray. So we have the angle R, that is the angle between the reflected ray and the normal. It is between reflected ray and normal. Right? Now, if we talk about the laws of reflection, so we have two laws. First law, without any order, like they are not in any certain order. So one is that the incident ray, normal, incident ray, normal, and reflected ray both lie in the all of these three, they lie in the same plane. All lie in same plane. Now, what does it mean? For example, we are having this as a plane. You can consider this is a plane that is a polished surface. Okay. Now, light is incident like this. Okay. This is normal and this is reflective. All of them, all of these three, they are in a plane perpendicular to it. Okay. Or if, for example, this is a plane, here we have incident ray, this is the normal, this is reflected. All of them, they are in the same plane, in the plane, in this plane only, right? So all of them will be in the same plane. You can't have the incident in one plane, normal in another one, and reflected ray in the another one. No, all of them will lie in the same plane. Okay. Second is that the angle of incidence is equal to the angle of reflection. Both of them will be equal. And this both of these two laws, they are applicable on all the kinds of reflections. In lower grades, you have learned that we have regular reflection, irregular reflection. So for both of them, the laws will be applicable, right? In both the cases, the laws will be same. Okay, so that is reflection. Now, if we talk about refraction, so that is the bending of light when it travels from one medium to another. See what happens. This you have learned in grade 10th as well, refraction, that okay, when the light goes from rarer to denser medium, it will bend towards normal, right?
Yes, ma'am.
Right? Do you remember about the concept of refractive index?
Yes, sine.
Yes. Sine I upon.
Sine or.
Yes, it is refractive index. That's correct. That is the Snell's law also. And we have another formula for refractive index, which is the speed of light in air or in vacuum to the speed of light in the. Okay.
Okay.
Now here, this is the incident ray. It is making angle I with the north. This one is refracted ray, which is making angle R with the north. Now the question is, if this is the, see, if we consider the original path of the light, this was the original path, right? But it bent towards the north. If it is going from rarer to dense. And if it is going from denser to rarer, it will bend up. Now the question is why the refraction happens. Means why this bending is happening. Do you know the cause of refraction?
When a light travels from denser to rarer medium, the ray goes away from the normal.
Okay. When it is goes from rare to denser, it will bend towards the normal. Fine.
Yes.
why it is bending? Do you know the reason why it bends? Like why it goes towards normal, why it goes away from normal?
Like when light has to go from one medium to other medium, it has to go under refraction.
Okay. So when light goes from one medium to another medium, you know the concept of refractive index, that mu, that is C over V, right? Let's say this is having the refractive index mu1. This is the refractive index mu. Will the speed of light same in both the mediums, or will it be different?
It will be different.
That is the cause of refraction. That the speed of light is different in different mediums. And because speed is different, the wavelength of the light also differs. Okay, we have this relation that the velocity is equal to frequency into wavelength, right?
Yes.
You have learned it in chemistry also, you have learned it in physics grade 10th also. Now, frequency is something, it has been asked so many times in CBSE question, MCQ question, which property of light remains same? And this will come again in electromagnetic waves also. That which property of the light remains same when it changes the medium? So that is the frequency. It will remain same, whether the light is getting reflected or it is getting refracted. But velocity and wavelength, both of them will change. Okay. Now, as the velocity changes, wavelength also changes. That is the cause of refraction. Now, the thing is, why it is going towards normal when it is going from rarer to denser? See, when the medium is rarer, means, let's say this mu1, that is of rarer, and mu2 is of denser. Which one will be greater, mu1 or mu2?
Uh, mu2.
Mu2. Okay, mu2 is greater. So, in which case, speed will be more? In medium 1 or in medium 2?
Medium 1.
Correct. In medium 1, speed will be more. So, that means when it goes from rarer to denser, it is getting slower. In the same time, it has, like, its velocity has decreased now. Okay, earlier it was moving at v1, now it is moving at v2. Its velocity is decreased now, so it will try to decrease the distance. And when something tries to decrease the distance, for example, when you try to take a shortcut, you were going like this, okay, you thought, no, I have to take a shortcut. So in mechanics in grade 11th you have learned displacement, that is the shortest path, right? And the straight line, that is always a shortest path, straight line path. So that is why it is trying to bend towards normal, so that it will get a straight line path. It has to cover less distance.
Okay.
Okay, you got this concept? Why it bend towards normal? Because when it goes from rare to denser, the speed will decrease. Now its velocity has decreased. It wants to take a shortcut. It wants to take like a simple path. So it will go towards normal. And when it goes from denser to rarer, speed is more. Now it can cover more distance. So it will go away from normal. It can cover more distance in the same time, right? So that is why when it goes from denser to rarer, it will bend. Okay, so we can say that the main cause of refraction is the change in refractive index, which causes change in wavelength as well as velocity. Okay, and we have covered here one MCQ, that is which property remains same during refraction, that is frequency. There is one another, I will tell you. See, basically two kinds of MCQs are asked here. Out of V, F, and lambda, which property? And in ray optics, in NCERT question, we have the first numerical back question that is based on the same concept. Which velocity, like the property, they will ask you to find frequency, wavelength in two different media. So we know that frequency that will be same. This will remain same in both the cases of reflection and refraction. But if we talk about velocity and wavelength, these are the one which remain same on reflection, but they get changes, like they get changed on refraction. In case of refraction, they will change. Okay?
Okay.
Any doubt up to here?
No, no.
No. Okay. And if we talk about refraction, laws of refraction, so you have a first law, that is incident ray, normal, and refracted ray. I'm adding here a few words extra. All incident at the same point. This thing is similar in case of reflection and refraction. All are incident at the same point. But this point is situated at interface of two mediums. All lie in same plane. Now, what does it mean? In case of refraction, here we have one medium, here we have another medium, right? When the light is incident here, this is the normal. This one is normal, right? And this one is refracted. Let's say it is bending away from normal. All of them are at this point, right? And this is the boundary basically. Boundary, or we can also call it interface of two media. Okay, two different media. And the second law, that is sine I, ratio of sine of angle of incidence to the ratio of, ratio of sine of angle of incidence to the sine of angle of refraction, that is constant, and that constant is refractive. Now here, this is what you have learned in grade 10th. Now how we will use it here in grade 12. For example, this is the medium 1, this is medium 2. Now light is going like this, angle of incidence, and this is angle of refraction. Now how we will say here, see, in grade 10th, you have learned in all the cases in generally that light goes from air to any medium. Okay, now here I am saying from medium 1 to medium 2. Let's say from it is going from water to glass. Okay, so how we will use this Snell's law? Mu1 sine I, that is equal to mu2 sine R. See, sine I is in medium 1. So that is why mu1 sine I. R, that is in medium 2. So mu2 sine R. Now, sine I upon sine R, that is equal to mu2 upon. This is very, very important. This relation will be used when we will find out the relations for refractive index by spherical surfaces. This will be used when we will talk about total internal reflection, this relation only. Okay, so it will be used at multiple places. It will be used when we will talk about real and apparent depth. right? So these are certain aspects where we will use this relationship. So you must remember this relation when we have mu1 in that medium, like where you have angle of incidence, it will be mu1 sine r, mu1 sine I. And if r is in medium 2, then it will be mu2 sine. Then we can find the ratio and we can write this as mu2 with respect to 1. Okay, mu2 with respect to 1. Such refractive indexes are known as relative refractive index. Relative means when you are comparing it to something. Like all the values you have used in grade 10, for glass you have used 1.5, for water it is 1.33, for dense flint glass it is 1.6. They were all with respect to air. Okay, all those values are with respect to air. But here, and those values are known as absolute. They are fixed. These are not fixed because this will depend on which medium we are referring to, on which medium we are comparing. For example, if we are finding the refractive index of glass with respect to water, that will be a different value. If we are finding the value of refractive index of glass with respect to, let's say, turpentine, so that will be a different value. Okay, so relative refractive index, that is not absolute. The values which are with respect to air, they are absolute. Okay, if you have any questions, any doubt up to here, you may ask any query.
Okay.
No doubt.
No.
And Melissa, is
I
this
think up here,
sufficient for demo?
yeah, it was sufficient for the demo purpose. Jashita, can we just wrap up, or you any questions, or you have
No question.
it fine? Any questions, any doubts?
No, sir.
Okay, great. So I think we can just leave, right?
Okay, Jashika.
Yeah, thank you.